Hi, I'm here with Mr. Sullivan, the science research teacher here at Dana. So, Mr. Sullivan, what is the weather going to look like this weekend?
Well, that's an interesting question. And so to answer that question, I've devised a new instrument we're using here throughout the department at Dana Hills.
Sounds good. Can you show me it?
Yeah, I'd be more than happy to. It's right down here. Well, we got to be careful because I don't want anybody stealing this idea. So if you would, just kind of keep this under wraps until we've got it all, until we get all of the bugs worked out. But
for sure.
What you can see here is I'm trying to integrate a couple of disciplines. I'm integrating geology with this big piece of basalt. Notice it's a vesicular piece, so it's got a lot of holes in it, as well as the concepts that go along with meteorology or the study of the atmosphere. The way this works, I mean, it's a very simple thing, and I try to simplify things as much as I can for just the general public. So what we've got is this piece of rock, this giant piece of basalt that I've got suspended above the ground by these ropes. Now, the way it works is that the color of the rock specifically is dark. Basalt is normally a darker rock, ocean floor type rock. Now, what ends up happening is that if it were sunny out, the thermal capabilities of this vesicular basalt would be absorbing that heat, right? Now, because that absorption goes into the rock to the touch, I would feel it and go, it's warm, therefore sunny out. Make sense?
That makes sense, yeah.
Okay, so as long as that makes sense, so should then the opposite. That same ability of that rock to absorb thermal radiation, in the absence of heat, will lose that thermal radiation and then cause the rock, believe it or not, to cool down. As it cools down, we all know that cold really isn't anything. It's an absolute absence of heat. But as it loses its heat to the touch, it's going to feel cooler to the touch, meaning that either the sun isn't out or it's basically a cooler temperature day. That sun may not be out because you've got cloud cover. It could be lots of things, but normally, as a thermometer, the way this is designed, if it's hot, it's warm out. If it's cool, it's cool out. Hence the idea of a thermometer.
That's pretty genius.
I think it's going to work pretty well. Now, other things that I'm kind of working out here, and I believe this is going to work out well, is that even if you look in the sky here today, you can see it's cloudy. We've got this atmospheric river coming up from the south, and it's been sprinkling all day. But right now it isn't. Right now there is no water, no precipitation falling from the sky. So check it out. If you look close, this is dry. So as a rain gauge, if the rock out in the open is exposed to a lack of rainfall or precipitation, it's going to be dry. So right now, look, dry, no rain. If it was wet, rain. Hence, another indicator, more of a rain gauge type of an indicator or fully precipitative. Now, in this case, with all the precipitation that's occurring, it also deals with snow. Another great reason that this is dark in color is it's going to contrast if the temperatures drop below 32 and sustain that for a period of time. You're going to end up turning this water falling to the sky into snow, and then hence you're going to allow an accumulation of that white material on here, contrasting perfectly even from my room. I could look outside, see wet rock, it's raining. See a dry rock, it's not raining. More importantly, see a white rock, it's snowing. Get out snowboards, right? Okay? Now, the last thing that I've worked on here is the fact that it works as an anemometer. An anemometer is a gauge that, determines wind speed as well as wind direction. Now, if I were to use various sides of these calibrated to the amount of wind that's blowing, if this is actually moving, okay, then I could conclude that we end up with what's called wind. Atmospheric flow, that fluid flow of air in a horizontal manner ends up, we call wind. If this moves, even from my room, I don't even have to feel it. I could be behind a window, look out, and I would know it's windy. Now, the things that I've been kind of fine-tuning, this is stuff that I'm kind of keeping under wraps, is its ability to become what's called a well, more or less a sling psychrometer to determine relative humidity. I'm still working on those. But another thing that I've determined, and I carry around these in my pockets, and I've handed these to each of my students. These are also basaltic. Notice also, I don't know if you can see this over here, but I dropped the instrument on the ground and noticed that nothing happened to it. Now, you buy an instrument off Amazon, you drop it on the ground, you mess it up, you're out $50, $60, $100, $200. Still functional, still dry, no rain, right? Portable, works perfect. In fact, I think that we're probably gonna make a mark in science here at Dana Hills.
Thank you for sharing that amazing new invention with us.